Hi everyone, in this section we're looking at two further graphs that we use for our numerical data. And so the first one that we're looking at is a dot plot. Dot plots are really useful for small sets of data. They end up looking a lot like a histogram in terms of being able to identify those features and look at shape. But instead of having columns of frequencies, we're using a dot to represent each frequency or each occurrence of that particular value. It's really important when you are drawing them, if you do have to construct them, that you think about keeping those dots are the same distance apart. So we want to end up with a stack of 5 dots on one particular value, the same height as a stack of 5 dots on another value. So just be careful with that. Normally you're given a grid to work on, so that does make it a bit easier. So the example we've got here, we've got some data points and we just need to plot them onto that grid there or onto that scale. And so if not all of your numbers are filled in, you might choose to actually pop those in as well. So if we just pop them there so that it makes it a bit easier to see what we're doing. And then we're literally working our way from left to right with the numbers and putting in those dots. Or you may choose to look for all of the number ones, count how many there are, so do a mini frequency tally in your head and then draw them in. But if I'm just working left to right, so I can see I've got a number 7, and so I just put a dot at the number 7. I've got a 4, same thing, and working my way through. 2, 1. I tend to cross them out as I go, just so I can keep a track of what have I done. But if I need to refer back to the data later on, I don't want them crossed out, my option is just to use a highlighter or just put a mark underneath the number so that I can see where I'm up to. Okay, lots of little strategies. It's one of those things, again, unlikely to be asked to do this in an exam, possible in a SAC. But then again, we never know. The exam for 2020, they got them to draw a box plot. We haven't seen that for a while. So you never quite know what VCA are going to ask you to do. It's good to know how to do each of them. As I said, just try and keep them nice and evenly spaced. And then once we've drawn that dot plot, so we're completed now, we can see an idea of the frequency of each of those values. We can see an idea of the shape of the graph. Okay, and much like our histograms, we are describing things in the same way. So we're talking about shape, center, spread, and outliers. Okay, and so here you can see we've got some examples of what the shape of our dot plot, I should actually say dot plot there, should look like. So again, we have, if we start on the right, we have our symmetrical. So nice and evenly shaped on both sides. In the middle, again, we've got our positively skewed, so it's tailing towards the larger numbers, the positive direction. And the left-hand side, we've got our negative skew. So if you find it a little bit hard to judge, you can just draw sort of a curve over the top of the data to give that general shape so you can make a judgment a bit easier. Okay, then the next type that we're looking at is a stem plot. Sometimes we call these a stem and leaf plot. So we're thinking about retaining the actual data values here, and this is good for any type of numerical data. So it doesn't have to be whole numbers. We can display decimal values here as well. And so it's just a reminder that our stem or our central column is where we would put. So here we would have the key value. Okay, generally it is however many digits you need to show. So it could be, you know, if we're dealing with hundreds, we could actually have 2 values in that stem. We've said here the leaf contains only the last digit. So you just want single numbers in your leaf coming off that stem. When we are recording those, we want them to be in order, so the numbers in the leaf are in order. That's important because later down the track, when we want to find the median or the quartiles from our set of data, we don't have to then redraw it. We don't have to reorder the data. So often you'll be instructed to do an ordered stem plot, as we are in the first example here. One big thing to take note, we must always include a key with our plot. Okay, the reason being, if I take what I've got here in this example, that 30 with the divider there between the leaf and the stem, that could mean 303, it could mean 30.3, it could mean 30.3 million. It really depends on what we've said in our key. So we have to make sure that we do include that. So if we look at the example we've got here, we're asked to organise this set of data into our stem and leaf plot. Now we're going and we want to look at our values. So our range, we're going from 2 up to, I think our largest there is 35, looking at those. So we are going to have our tens and then our units. So our tens in our stem. You don't have to write that, but you can. So we've got 0, 1, 2, and 3, and that's as far as we need to go. And then in our units, we are looking this time for everything that is below 10, so any single digits. So we've got a 4, a 7, an 8, and a 2. So as we said, we want to put those in order. So that means we want to start smallest and write those numbers in. And again, much like the dot plot, we want the numbers to be evenly spaced, so that then when we come to look at the shape of that stem plot, it's something we can see straight from our graph rather than having to reimagine what it looks like. And so again, if we now look at our tens, so we've got a 13, an 18, an 18, a 16, and a 10. So again, in order, 0, 13, 16, 18, 18. Into our 20s, we have a 21, a 27, and a 25. So again, in order, 1, 5, 7. And finally, in our 30s, we have a 34 and a 35. So 4, 5. So you can see there I've tried to keep those numbers nice and evenly spaced, so I can see, you know, if I wanted to know the modal interval, the largest frequency interval, I can see that that's between 10 and 19. Okay. So just some more information about stem plots. Sometimes we find that our frequencies within, if we were looking at those tens, is actually quite large. And so if you look at the first example here, we can see we've actually got a really large frequency sort of sitting here in that 2 row. And so it might help us to break our data into different intervals. So in this case, if we were to say that the key here, so 2, 1 was 21, we could say, well, this first row is from 10 to 19 and then from 20 to 29. We may choose to break our intervals up a bit more. And so what we do if we split that stem into halves means we're actually splitting that interval into half. So we might be saying now we're actually going from 10 to 14 and then from 15 to 19, 20 to 24, and then finally 25 to 29. So it's that whole idea of splitting up those intervals. Again, we're going up by 5s this time. Even then, we might have a particularly large data set that's over a very small range, and so we're not seeing sufficient spread of that data and we want to do something more. So we actually are able to split into fifths. And what that means, again, we're splitting the intervals, so we're actually counting in 2s. Okay, whereas the halves, we said we're counting up by 5. And the original, counting up by 10. So it's not often that you see the fifths done, but if we did, that would be 10 to 11, 12 to 13, 14 to 15, 16 to 17, 18 to 19, and then obviously over into our 20s and so on. Okay, so not often that you do see that. It would be in the case where there's a particularly large set of data and it was quite bunched over a small range there. Okay, so when we move on to interpreting the shape of a stem plot, much like a histogram, Okay, we're looking again for any skew or anything that's symmetrical. And so what you want to do is actually literally pick up your piece of paper and turn it sideways. So if I was to turn this stem plot here, sort of rotate it that way towards the left-hand side, and so I would have my numbers across the bottom, my scale, and then I would have my frequencies. If I imagine each of those columns like part of a bar chart, which is why it's important to have those numbers evenly spaced, and I would actually put a space between each of them so it's a bit easier to see. We can see that we have that sort of symmetrical shape to our data. If we look at the skewed values here, remember that's where it's important to think about our data, about where it is tailing off to. So again, if I imagine each of those lists of numbers in the leaf like a column in the histogram, I can see I've got the bulk of my data here and it's trailing off towards the smaller numbers, so that makes it a negative skew. Whereas the second one in the middle here, I've got that peak and then trailing off towards the larger numbers, so a positive skew. We're also able to do what we call back-to-back stem plots. And so that's where you would have a second set of data off to the left-hand side of that stem. And so we've just included here a couple of examples. So that's why it's important if we're looking at the shape here, we're tailing off this direction and it's towards the smaller numbers. So that means a negative skew again. Same on this side, we're tailing off towards the large numbers, so a positive skew, and then something nice and almost perfectly symmetrical there, okay, giving us that approximately symmetrical shape. Okay, so just a little reminder, when we are commenting on our dot and stem plots, we are doing it in the exact same way as we do for our histograms. Okay, so we are usually pointed towards particular things to comment on, but if not, we want to in these 4 things. So shape, center, spread, and outliers. So make sure you're commenting on all 4. And here again is a little template for you to fill out. It is the same template as we used for our histograms. As we said before, there is also the ability to draw these back-to-back stem plots. So if I wanted to compare data between 2 different sets, so in this case I have the final exam scores for history and for literature, and all marks are out of 100. And so we want to construct a back-to-back stem plot and comment on those distributions. And so what I'm going to do here, instead of doing like a full comment on both of those sets of data, I'll do a comment for one, and then we'll also start to talk about how we might compare data sets. But just note that comparison will come in a bit later when we start bivariate data. So first thing, we want to do a back-to-back stem plot. So that means our stem is going to be down the centre of our graph, and we'll have history coming off one side and all the numbers there in one leaf, and then literature coming off the other side. And again, all those numbers in one leaf on that side. And so it doesn't matter whether you go history on the left and literature on the right or other way around. I'm going to do history on the left. So if we were doing this in our books, I would expect that you would be using a ruler, but as I've said before, unable to do that on my laptop here. So pardon the poorly drawn lines. We also want to think here, because the stem is common, that we have to capture all of the data. So when I'm looking, what's my lowest number here? I can see a 35. I haven't got anything below the 30s. And then what's my largest number? I have one in the 90s. And so I just need to make sure that I represent each of those values. In my stem there. I need to draw a key, and so I can pick any number at all. It doesn't have to be one from the data, just as long as you're saying in my stem plot, 4 in the stem, 7 in the leaf represents 47, number 47. Okay, so I'm going to go through from the beginning with history and put in all the values. So I'm looking, is there anything in the 30s? No, so I leave that blank. Now I'm on to the 40s, anything in the 40s, and here we want it to be ordered. So check, we've got a 42, and that's all. So I've put a 2 there in that leaf. Starting from the centre, working your way out. So you want that 2 as close to that leaf, and then you're going to work evenly on your way out to the left for history. Then we move on to the 50s. I have a 58. 60s, I have a 67 and a 62. So again, in order, 2, then 7, working my way out. 70s, I have a 75, 78, 74, and 77. So 4, 5, 7, 8. Into the 80s, I have an 82 and an 84. So 2 and 4. And finally, the 90s, I have 2. So it is worth checking how many values you've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And have I represented them all here in my plot? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Moving on to literature, same thing. So starting this time in the 30s, I have 35. In the 40s, I have 48. 50s, I've got 56, 56, 51. So 1, I've got 2 6s, so I represent them separately. In the 60s, I have 68, 63, so 3, then 8, working my way out. 70s, 72, and 72 again, so 2 and 2. 80s, I have 83 and 84. And nothing in the 90s. And again, a quick count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have all of my data there. Okay, now when I come to comment on that, so let's just comment on history. We'll just comment on history and do a full comment there. We want to comment on shape, on centre, on spread, and on outliers. So remember, you can write this using the template as a complete sentence, or we can dot point. Okay, so our shape of history. Looking at this, I would say we are approximately symmetrical. Teeny tiny little bit of a tail starting there, but I don't think it's enough to throw us into a skew. So we would say approximately symmetrical. And remember, it is exceptionally rare that we would get something that is exactly symmetrical. So we're always making that comment approximately symmetrical. Centre is given by the median. So this is where it's important that we have got our data in order. So our median value out of our 11 values, I might just move down just a touch. So our median, our position for our median, add 1 divided by 2. So it will be the 6th value. So that means the 6th value starting either from the top or from the bottom. When I'm counting those, I have to keep starting from the leaf, from the stem and working out. So I've got 1, 2, 3, 4, 5, 6. If I was to start from the maximum value from 92, I would have to count in from the left-hand side. So 1, 2, 3, 4, 5, 6, and see how I land again on that 5. Now that means it's not 5, but 75. So centered as given by the median at 75. The spread, remember, is our range. So as given by our range, maximum 92 minus minimum of 42. So our spread is 50. And looking here, there are no apparent outliers. So nothing sitting sort of outside of the expected data range. So that would be a comment on a single thing. If we were asked to compare the two distributions, the key things that we would want to be looking at are the centre and the spread. And we'll talk more about that once we start looking at that comparison of multiple sets in our bivariate data. But for now, it's just about commenting. If you did have to say something, we would look at those centres and say, is one of the medians higher than the other? Meaning on average, using the median as our average measure, we can say that one set scored higher than the other. But for now, that's all we need to be able to do. Okay, thanks.